Hello, it's your old virtual machine shop instructor, Ed here, CNC dude from Suncoast Technical College in always sunny Sarasota, Florida. Yes, this is the same shirt I was wearing yesterday. Sorry. I thought I'd change hats. This is one of my swag that I get occasionally. I could use a Mastercam one, so here's a Mastercam one right here. Wink, wink, Clinton and Pete Mancini. Um, uh, the question was, let's see if I could bring up. I put this add on to NC file reduction. I said it was part 3. It's really part 2. And he's running on a small machine. Now, all us guys from the 80s know how to deal with this stuff. Sub-programming. And it's probably still relative to people that have older machines, because they're still good machines. They're just very limited. They were only meant to do 2.5 axis parts, not really 3D parts. It wasn't really invented then. We were all hand coding, so to make arcs and curves was like the only thing we could do curve was like in the YZ plane or the XZ plane. So you couldn't do a compound curve or whatever the heck they call it. But and then so sub-programming. And sub-programming was good because it saved us from typing the time because we're on the control typing. So sub-programming. Let me pull up my go-to notepad up here. And okay, the question was, I'm trying to run duplicate multiple parts. One part is currently 18K, which should be 12K after we shrink it. Do you even know of a way to loop back through the same code but only change the X value? Yes. So actually, we used to do this on a job in New Hampshire. We had like 3 vices in a row, a bar strip, and we were making flanges, and it's the same program over and over again. So we would just make the program and then move it and re-zero it, move it, re-zero it. So we could do that through sub-programming. And you can do it without multiple work coordinates, but you can kind of figure out how to do it after that. I'm going to go on to the trusty. I'm having these printed for the class. I've been using the older version. This is the newer version, which I think they only changed the VF and EC up here. And the SL lathes are now ST lathes. All right, let me, I did this so I can find old trusty M98. Subroutines, page 105. How can I get to page 105 here? I'll just keep on looking. Keep on looking, right there. Now, we want to find the area that talks about it. We used to use these a lot. Sub-programming or subroutines right here. And there's an example. This is a great go-to book for any Fanuc style machine, and it does apply to a lot of Japanese machines, like even the Okuma. I think I remember it can do this on the OSP control. Okuma's got its own unique codes, but in sub-programming, you can call up repetitious things easily. The quickest way you can do it, I'm just going to write some code up here. I'm going to start with %, give it a number like 1000. I'm going to call this the main program. I should use caps. I should leave my caps lock on. Some machines don't like the small font. I mean, the small caps. Oops. Caps lock on. Okay. So let's say your onesie program is called 1001. So you're going to go M98 P1001, right? And then you run that whole program. And then you say, oh, I want to make another one that's, I think you said 3.5 inches around. So at the end, you're going to go G0, G90, X0, Y0, right? Assuming you're clear. And then at that point, we used to use a G90. Oh, sorry. Then we would do an incremental move. G91, X3.5. Then we'll say G92, X0. We just reset the 0. We didn't reset the work coordinate, but we just shifted the X and Y. And at that point, we could do M98 P1001. Just run the same program again. And then you can build this into what they call a loop. So if you made this to be your shifting program, so we'll call this the shift program. And then you would call up that program and make it loop like 10 times, or 3 times. So you would say call up M98 P1001 L3. That would do that. So some programming, I think it goes 4 levels. So you got your main program. How they used to do it originally was main program and like drill cycles. All the holes are the same X and Y's. So your longhand out of a CAD can would be like really long. And we would write all the coordinates for the just the drill cycles. You got to keep anything that's unique outside of the sub. So you would call up the unique tool, unique height offset, unique drill cycle, drill that hole, then call up the sub program, and it jumps to the next level, and it calls up all the X and Y coordinates. And at the end, you have to put an M99 to get back to where you were in the main program. So if you're actually going to use, like, let's go back to using this as main program. Sorry. You have to remove the M30 from the main, and you got to end it with M99. It has to find a way back to its root, the root of the tree. So now you're saying that this is going to be where the main program starts right here. So we did it longhand, and we just run this program over and over again, and just do it 3 times. All you need is with this little dinky program, and you're just repeating these over and over again. Like copy that, put it there. That's number 2, and then number 3, right? And if you want like stops in between, you could say M01 there, and M01 there. I kind of forget though, if you hit reset, do you lose position? I'd have to experiment with that one. I haven't done this in a long time, so. I'm sorry, what we used to do. We used to go back to the original home and reset the 0 there. So all our ducks were back in a row again. So this would be the end, let's see, P1001. And then we would go back G0, G90, X0, Y0. And then G91. X, what is it, 3.5 times 3. All right, X minus 10.5. And then G92, that one. X0, Y0, right? Or X0. Maybe we got to put them both. And then you'd be back home, and then I would now just send. Assuming the tool put itself in the right position, or maybe you want to do, I don't know, let's use the old school. We'll go on old school on this. G28, C0, and G28, Y0, M30. That's it. That's your little program that'll call up your big program 3 times. then go back to its original position. Forgot the percent sign. And be ready for the next part. You could do it with 3 vices. Every time you don't need the G90 to it, you just need to call up a new work offset. So let's see. This one's the first program. Then oh, let me see if I can. Let me write a duplicate. I'm gonna save this one. File save as on my desktop. Sub from main. I'm just gonna call it. Oh, not a good typer. Okay. Erase that one. Main. Oops. Parentheses. Main with G54, G55, G56. Okay. All right. Remember, you cannot have the G54 in the main program. You got to strip those out. So we're going to call up the work coordinate, number 1, right, in the beginning. Then I'm going to say M98P1001, which is your program, which has no work coordinates in it. Then when you're done, you assume like it goes up in the air, but you got to end with M99, so now it's going to come back to this position. And you just say G55, right? M98P1001. Do its thing, G56, M98P1001. Does its thing, and at the end, I wouldn't have it the table coming back home all the time. I would just have it come back at the end, and maybe you want it to be somewhere in the middle because it moved to the right. So if I'm going totally old school, remember you're in G56 now, so maybe say we go G55, G90. Let me make sure I get wrap it in here just in case. And we'll say that, put that X0, which should be somewhere in the middle, and then put in G91, G28, Y0. Now, the assumption is you went home, so, and this would be the end of the program. That would be it. Oops. So that would put the table somewhere in the middle, assuming 55 somewhere in the middle, and then this would bring the table to you so you can unload. Put the parts in, press cycle start, it starts the G54, does that program. Now, it's not the most efficient way because you're calling up the same program 3 times, but if you get really into it, you probably could face mill all 3. Believe me, we used to have to do that, and it's a lot of typing. This is the quickest way to do it. You can just all you do is calling up and rerunning your program and shifting it around. So you can use it with multiple work coordinates, or you could do it with the G92 method. So either one would work. Okay. I try to keep these under 10 minutes. I'm doing my best, but so this is sub-programming, and where's my little book here? Right here. This is a example right here. It says tool 3, position, turn the spindle on, come down, do a drill cycle, and it says call sub-program 10107. Where is that? Must be here somewhere. Page down. Here it is right there, sub-program. So the sub-program has, see, we've got some G98s in there. It's got to shut the drill cycle off, and it's got to go home. And M99, which is going to return to here. Personally, I put all the, sorry, I had to make sure it wasn't a corona sneeze. I put in the go home stuff up in here, right? But everybody's got their own way of doing things. So this is, imagine you had 100 holes to do. You could copy and paste and make a huge program out of this, but so that's the sub program, and there's some more right here. Now there's one called a local subroutine. I don't know if our Kuma is capable of it, which means in subprogramming, you got your M98 is calling up a totally separate program. It's going to have a totally different number. In an M97, you can bury the program in. It's like one program, and it goes and looks for it. It goes and looks for it after the M30. So right here it says M97P10, so it's going to look for the N10, and it's going to run this as a sub. So it's really, when they call it local subroutine, which means it's in the main program, which is kind of nice. If you, we used to have to load all the subprograms in the main program when we were hand coding, but this would be like one shot deal. You just load the whole thing in. So if it's capable of that, that's a preferred method, especially if you're going to run it over and over again. These are very good examples of how to do this. I'll have to put the link to the Haas website link, because this is in the manuals, but sometimes it can be hard to find. Okay. Have a nice day. I got to go work on my RV, and hopefully I can go camping somewhere. See you later.